Hello students, and welcome to the final video of this lesson. In our previous video, we went over how to actually solve for volume when we have a solid of revolution going around the x-axis. But in that video, you might have been wondering, well, can I go in different axes? Can I go over the y-axis? The answer is, of course, yes. So let's get started. So here's our question. We have two functions here. We have the square root of x and x minus 2. And we want to find the volume when the region is rotated about the y-axis. So we're going now this direction. And it's going to create a solid of revolution, of course. Again, try to envision what is that shape going to look like when it revolves around the axis. It's going to kind of be some sort of like weird misshapen yo-yo thing happening. But what you need to notice is that, all right, since I'm rotating around the x-axis, my slivers are going to be this direction. We're going to have a change in y. The only way I can have something with the change in y, dy, I need all my functions to be in terms of y. Well, right now I have y in terms of x, so I need x in terms of y. In order to do that, I'm just going to square both sides here. So I'm going to have y squared equal to x, and then here I need to add 2 to both sides, so I'm going to have y plus 2 equal to x. So that's what we're going to use. I'm going to use these in terms of y. So when I write out my function here, so volume is equal to pi times the integral from, looks like we're going to be not using the x values, we're going to be using the y values in this case. So I'm going to be going from the lower to the upper, so -1 to 2, -1 to 2. And what is going to be the outer part, the rightmost part of this? Well, that's going to be that linear function y plus 2, and of course minus 0 since we're going across that x equals 0 line. And then that's going to get squared minus the inner part, which is going to be y squared all squared. Of course, it's also minus 0 in there. And this is dy. So really, not much has changed. We're just really kind of tipping everything over onto its side. And so what we want to do here is just go through the fundamental theorem of calculus. We're going to speed up the video and we're going to do all the arithmetic. So let's see it. Okay, and that is going to be our first answer in this video. It's 72 pi over 5. And I did make a small mistake. If you caught it, great, but when I was doing the antiderivative, or actually when I was multiplying everything out, I wrote right here in this spot 2y instead of 4y, which was a mistake and kind of messed up all my arithmetic at the end. But that was just like a small tiny error. And, you know, since my work is accurate, if this were a free response question, you would still get most of the points. You're not going to lose points for, you know, you're showing in these parts here that you know the calculus. Everything that comes after does not get heavily weighted on your score. So don't worry about that if you make a small calculation error moving forward. So the next thing that we're going to want to do is we're going to want to find the volume when the region is rotated about the line x equals 4. So x equals 4 is going right here. So what is our outer part? Well, that's going to be the parabola y squared, and then the inner part is going to be the linear y plus 2. Then they're all going to be subtracted by 4 because that's our new axis of rotation. So this is going to be kind of a weird like hollow ball, I guess, would come out. Maybe an upside down ball. It's hard to envision sometimes with these. So let's go ahead and write out our function. So that's going to be volume equals pi. Our limits are going to be -1 to 2 still. So -1 to +2. And my outer, I said, was y squared. We're subtracting the 4, so -4 squared minus the inner, which is y plus 2, subtracting the 4 still, squared dy. So let's do these calculations, and hopefully I don't make an error this time. But even if I do, that's okay. I'll catch it, and we'll talk about it in just a second. So our volume in the second problem is going to be 108 pi over 5. So hopefully you worked all of that out. And now we're going to move over to our final problem in the video, final problem in the lesson, is when is the region when it's rotated around the line x equals 7. So of course x equals 7 would be over there. We're going to be rotating, around that spot. So what are we going to do? Well, the process hasn't really changed. So we're going to have volume equals pi. Our y values are still going to be -1 to 2. And in this case, well, what is the outer part for 7? The outer part is going to be y squared minus, or just y squared. In this case, it's going to be y squared minus 7. So we're going to have y squared minus 7 squared. And then we're going to subtract it. And then what is the inner part? Well, that's going to be the linear function. So y plus 2. So y plus 2 minus 7. Well, y plus 2 minus 7 is going to be y minus 5 squared dy, doing some simplification in this case. All right, so let's go ahead and calculate what comes out here. Okay, and that is going to be our final answer. The volume for the axis of rotation when it is x equal to 7 comes out to be 243 over 5 pi. Again, I know that these calculations can take a while. Know that sometimes the problems are going to be a little bit friendlier when you actually take the AP exam, but sometimes they can look like this and you just got to deal with it. So of course, if you do need any help with any of these problems, you can always reach out to me. We have one final lesson, so make sure you prepare yourself for that. And if you need anything from me, I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.